Alrighty, so let's see. Last time we finished up 5.3, right? Okay, were you able to finish up the homework from 5.3 group, given that we kind of went through a couple of them to give you an idea of what you should expect for 5.3 homework? Yep, okay, so with that, it leaves us with 5.4. So we're gonna start by talking about constant percent of change. Modeling is just where you actually use the real world examples to actually show how this is used in real life. And we'll pull in some experiences of actually putting this in Zuru so you can create the exponential function in Zuru. So we'll get to most of that today. First three, I should finish the first three bullets, maybe four, we'll see. So with the first slide, so here is the first slide. It's called the constant percent of change. Now, do you remember when we did first differences a long time ago? So it's similar to that, and here's an example of when we say it's similar to that. So I'm going to actually create an XY table on the board. I'm going to create a horizontal one. So for example, it's going to ask you again, does the table or the information that you see in the chart model the data exactly, approximately, or not at all? So here's what our table might look like in my math lab. So of course I've got X and Y here, 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 here. I'm just making this up, guys, as we go here. So if I plug in a 0, my answer might be 0. If I plug in a 1, my answer is 1. If I plug in a 2, my answer is 8. If I plug in a 3, my answer is 27. If I plug in a 4, what's my answer? 64. And let's just leave the rest of this. I'll put one more here. If I plug in a 5, my answer is 125. All right, is there an equation that'll model this data exactly, approximately, or not at all? So we want to do something called, it's using the first difference, but we got to use the first difference and then do something else with it. So I've got to take the first difference, which is 0 minus 1 is what? Or is it 1 minus 0? It's always going to be positive. You want to take the absolute value. So we're always going to take this number and subtract it, and I get what? 1. Take these two numbers and subtract, and I get these two numbers, but you're going to do something else as well. So let's go ahead and subtract those two. What do I get? At 19. All right, let's subtract the next two. So if we subtract these next two, we get 14. Up there, 7. 5 to 30, or 37 for these two. What about the last two? 25 minus 64. What do I get? Is that a 61? Y'all check my math. Y'all know I make mistakes up here, right? All right. So now that you've got the, what do we call these that we just did? First difference. Okay. You want to take the first difference and divide it by the initial output. Now, we can't do this one. Why can't we do this one? Look at the initial output. The initial output is always going to be what this is. It said output. Didn't it say output? So we got to divide the difference, which is the first difference, by the initial output. All right, this one would be divided by what? 0. Can we do that? Never, ever, ever, ever. So we can't do this one. All right, divide this one by, here's the two numbers we're looking at. What's the initial output? You got two numbers here. These are both output values, but which one is the initial one? Is the first one. Yeah, so it's going to be 1. So what about these two? And let's write this so you can read it. All right, and then what about these two? And then these two. So now, if when you divide those numbers, the answer comes out to be pretty close to each other, then there is an equation that models the data exactly. Alrighty, so we just subtracted these two, put it here, subtracted these two, put it here, subtract these two, put it here, subtract these two, and keep going and divide by the initial input. Alright, questions? Now, of course, I need you to do this on the calculator. What's 7 divided by 1? 7. Okay, we knew that one, right? 19 divided by 8? 2.375. 2.3. Okay, so 2.37. I'm just going to leave it like that. 37 divided by 27? 1.37. What is it again? 1.37. Okay, and then 61 divided by 64?
0.953. 125.
Okay, so approximately This is approximately 2, this is approximately 1, this is approximately 1. I'm just rounding these guys, and this is approximately 7. Now, in the homework, it might say, and I'm just saying, these numbers are not exact, are they?
No.
Would you call them approximately, kind of, sort of, close, maybe?
No.
You say no. When you're looking at it in the large scheme of things, 7 and 2 are not too far apart. But the homework might call this approximately, and it might call it exact. You've seen, I don't know if you guys saw a problem in the homework before where they weren't exact, but it called it exact. So it's a judgment call when it comes to this type of a problem. So I'm just saying, make your best judgment. It might call this approximately.
What would you call it?
I would call it approximately 2, just because I know what these numbers, I know what they come out to be, yes.
What's the largest gap that you would allow to be called approximate?
That's why I say it's a judgment call, because it's
Like
not,
your opinion.
like I can't, so for example, let's say if this number were 500, well, of course you know that's too big of a gap, right? But is 50 too big of a gap?
Yeah.
I would say yes. So I wouldn't call this exact. I wouldn't even call it approximately, but I'm just saying, would my math lab make that mistake? Would my math lab call this approximately? This is another judgment call. I wouldn't call it that, but again, I'm saying this part, you kind of got to use your own judgment with it. So you might be slightly different than what my math lab thinks the answer should be for this.
Does it kind of determine, is it kind of determined on, what the actual graph looks like?
Yes,
Like
it
the
is.
range of the
Yes,
graph?
if you look at the graph, this graph right here looks something like that. So they're saying, is there an equation that you can create that models that? Yes, we can. So it's saying, is it an exact creation? Is it an approximate creation? Or you ain't gonna get
Yeah,
close
so
to that?
those numbers aren't, they're not that big enough to really make.
Exactly. So when you ask me what's the range, it really depends on what the graph looks like. And 7 and 2 are not that far apart, that when you try to model it, that it's not gonna be so far off.
Graph, yeah.
500 would be. Would 21? Maybe. So you kind of need to look at the graph of the points. I would actually put this in decimals and see what those points actually look like. And see if you can draw a curve that'll fit those points. You know what I mean when I say that? So if you had data that looked like, here, let me just draw some. If you had data that looked like that, is there any type of curve you can draw that's gonna match those points? These points here? No, not at all. But if I drew another graph and my points look like this, could you say there's something that might be graphed to sketch that particular curve? Yes. So that's why I say it's a good idea to actually put the points in decimals so you can actually see if it looks like a standard curve, or does it just look like dots all over the place? So, questions? So that's what you're gonna do for this particular type of problem that you're gonna see in the homework. It's called the constant percent of change. That's why you ended up dividing it. So because it's you're dividing, that's why it's calling it a percent change.
Will you have something like this on the quiz?
Could it be on the quiz for my math lab?
No, like for you.
For my test, it ain't gonna be on the test. This part will not be on the test.
Will it be on the quiz?
But it could be on my math lab. Alrighty, so here is the next type of exponential function we're gonna take a look at. Do you remember what the standard equation for an exponential functions look like? Do you remember y equals what? What's the first letter I should put up here, variable? A, okay. What were the other ones that we talked about? A, B, and
K.
AK, okay. So there we go. That's my standard exponential function. A times B raised to the kx power. Now, here's what they want you to see. I can write this slightly different to represent decay and growth. And so I'm changing one of those variables that you see on the board. I'm changing one of these variables. Which one do you see me changing? A, B, or K? Yeah. Did A stay in the same place that it usually is? Yeah, so I didn't change A. So I'm getting ready to show you how I can change this. There's my A. B is now going to either be 1 plus R or what?
1 minus R.
1 minus R. K could be any number. They don't even put it up here for you to even have a concern about it. So don't deal with K right now. K, in this particular case, K is what? When there's no K, what's K? 1. So that's what they're saying. In this particular situation, K is 1. And you're not gonna have to put it, so don't put it there. I'm just letting you know K is 1. So because K is 1, I don't have to write it here. All right, you okay? Now, can you see that if B happens to be 1 plus R, that it's gonna be growing? Remember, in order for growth, I need A, B, and K to be what? Positive. So, if I have a number here, if I add 1 to it, and this number is going to be called the rate, like interest rate. This is going to be the rate. So, my interest rate might be 0.9%. It might be 0.01%. It might be 2%. So, this is going to be a rate. So, my question to you, if I have 1 plus some interest rate, or interest of percent of change, will this always be positive if I'm adding a positive number to it? Yes. So if I've got A is positive, B, which is all of this, is positive, and K, which is 1, is that growth? So anytime you see 1 plus R, it's growth. It's just adding 2 positives together. I got a positive 1 plus whatever the interest is or the rate is. In the next one, notice what B became this time. What did B become? It's going to be 1 minus whatever that rate is. So if the rate is 0.05, what's going to happen to the rate? It's going to decrease. So if I have 1 minus, again, this is a minus. So if I have 1, here, I'm going to put 2 zeros, minus 0.05, can I subtract that? I'm just making up my R. I'm telling you I'm making up R to be 0.05, which is my rate. Can I subtract? What's that going to end up being? 0.95. Aha! So now the value that's in here is how much now? Less than 1. And what did we learn about A, B, and K when B happens to be between 0 and 1? It's declining or decaying. So remember, if B is between 0 and 1, it's decaying. So in the homework, they're going to give you information for A and R. They may even give you X. They're going to give you information for A and R, and you're just going to plug those things in. So in this particular case, up here, if I had 1 plus 0.05, well, we just have 1.05. That still makes it positive. And it still makes it greater than 1. Okay, so this happens to be the one that I want to hold on to for decay. And of course, this is my growth. That last little bullet, again, you see here, that third bullet here that you see, it will give you the initial value. It's going to tell you the constant percent of change. That's your rate. A percent of change is how much something either went up or went down. Okay? What's coming up next towards the end of this section is we're going to use this associated with money. So you're going to say, hey, my initial value was $1,000 and my rate was 0.05. So I want to figure out how much money will I have after a certain number of years if my interest is 0.05. So we're going to eventually get to that towards the end of this slide. But that's why you're seeing it written this way.
Is this how they interest?
Yes. Yes, it is. So either your money is growing or going down. So if you want it to grow, we should put it in a very lucrative investment account, but you don't get a whole lot of interest out of any account at this point for in terms of banking is concerned. All right, questions? This next one says when you get to the homework, it's going to ask you to choose between quadratic, power, and exponential models when you graph them all on the same graph. And you want to see which one is going to be a better fit. So, example, here is my graph. One of my graphs look like this. Another graph looks like that. And another graph, let's do that one in black, looks like this. Which one is a better fit for the data? That's what they're going to ask you. You're going to have a quadratic one So again, maybe this is my quadratic one that's in black. You're gonna have a quadratic curve, you're gonna have an exponential curve, and you're gonna have a power curve. And they're just gonna say which one is the best fit for the data. You get to choose. If you put them all in decimals, which one looks like it comes to touch the most data points that you see? You understand what we're saying? Okay. Alrighty, so with that said, you can do the same thing with the log equations. Okay, so let's go to the homework really quick, because the next section is 5.5. Let's go to the homework. We are looking at 5.4. All right, here's number. I'm just gonna kind of scan through these just to see if anything looks unfamiliar. All right, well, here's something. Did we do that in the table that's over there to the on the my right, your left side of the board? Yes, you got to do the same thing. What's the difference between my numbers and these numbers?
Fractions.
You have fractions. Can you remember? You remember how to subtract fractions? Yes, and then divide. So remember, so for this particular one, again, if it asked you to do that, did it ask us to do this? It says find the exponential function that models the data. Do we have to do any of what we had to do over there on the first part of the board? No, it just wants to know what equation models the data. So what you gonna go do? Put it in Zuru, and it wants exponential, so we cut and paste. Let me see what the rest of, well, let's just go ahead and look at that one real quick. So copy the clipboard, right click in the blue, copy, go to Zuru. I don't have it up yet. Alrighty, so here, now up here from the top, which one of these do I want? Which one of these do I want from up here at the top? You see those? Which ones do I want? EXPR, that's for exponential function. Let's erase this so you can actually see. All right, just remember, here is the standard function that we're looking for. We're looking for something that A times B raised to X power. Okay, in this particular case, we want it to stay 1, but that's what you're looking to write your answer in the form of. So, let's paste our data here and see what we get. Paste. Alrighty. When you get your answer, can you see that it's going to write its answer in a certain form? It's going to show you right here. Let me make my screen bigger so you can see. Right here, it says once you cut and paste your data, it's going to write the answer like this. It's going to say A times E raised to the B raised to the BX power. In the My Math Lab software, it does not want to see it written like that, so we've got to modify it. So let's see what happens once we paste our data here. So I'm going to put my data. Alrighty, so there's my data. I'm going to hit calculate. Let me take my EX out. It should do the same thing. Let me just make sure. Okay, did you get an equation similar to mine? Yeah. Alrighty, so now this is not wrong. This is still correct. The only issue is My Math Lab doesn't want to see it with this constant E in it. It wants you to write it with A and a B number. Doesn't want to see E to the X power. So what we've got to do is a couple of things here. First of all, I've got times 10 to the negative 1. What must happen if you've got that exponent at 10 to the negative 1 power? So I got to move my decimal. So here, this is y is equal to 3 times e raised to the 0.69314718065. I move my decimal one place to the left. Why? Negative 1. So now I've still got the correct answer, but it's not written without the e in it. Okay? So, and then I forgot my x. Don't forget your x, guys. And that's a 6. So it's e being raised to the 0.6931 times x power. My Math Lab does not want to see this part written like that. See, that's e to the 0.6. It wants it written like this. So So it wants you to turn this into a number. What is the number that it wants you to turn it into? Well, we got to go put this in the calculator. So it's going to be 3 times, all of this is going to be my B value, but I won't know that till I put it into the calculator. So what is B going to be? All of whatever that is. Now the homework should say rounded or using a certain number. What is it rounded to? Doesn't the homework say what to round it to? Oh, let me look at it just to be sure. All right. Alrighty, let me close this window. Alrighty, I'm gonna look at the example just to see if they want me to round to a certain place. Alrighty, alright, let's see what they got. Therefore the exponential. So notice for this one, see that they've gotten at the bottom of the, here's the example, see what they have here? When you put it in, they want to see what A is. Excuse me, what A is and what B is. Here, A was 10 and B was 3 when you put it into the graphing tool that they put it into. And so they wanted to write the final answer. Where did I do with my final answer? Well, I thought I was going to write it as, there it is. That's what I was looking for. This piece right here. So you see at the bottom of the screen here, they wrote it as y equals 10 times 3 to the x power. So I got to figure out, for mine is going to be y equals 3 times what to the x power? Well, the what goes in is going to be this. So I need you to put this in your calculator and round it to the nearest whole number. They left theirs as whole numbers. I'm going to leave mine as whole numbers. So when I put mine in the calculator, what does it round to? And let's see. So I would need to go to my web calculator, which is here. And I'm going to clear. And I need E raised to the what power? Mine is going to be raised to 0.693147. I probably don't need this many decimal places, but I'm just doing it just because I want you to see what happens. All right, so I've got all of my numbers here, and what does that equal? Ha! 2. You got to round all those zeros, it becomes a 2. So all of that turns into 2. So if I go back to the homework again, let's close this window and shrink my screen back down a little bit. So on the board here, what did mine come out to be? A 2. So here, this is going to be 3 times 2 to the x power. Now what I'm curious about is I'm going to see if it requires that I write it with the parentheses in it. So I want to see if it works both ways. I know it likes the parentheses. I'm curious to see what it does if you don't put them. 3 times 2 raised to the x power. All right. Now, it does it with the parentheses, and you should follow suit, but I want to see what happens if I don't. Check my answer here. It likes it with or without the parentheses. So what I'm saying to you is you can write it like this, or you can write it with a dot here to the x power. Both of these are the same thing. Both of these are the same thing. It likes both answers. Check your example to see if you wrote it like My Math Lab wants to see it. So that's what I say, check your example to see if you wrote yours like My Math Lab prefers to see it. All right, here's the next one. And let's look at the example for a quick second. All right, it gave us all of those. Continue. Okay, guys, I'm just showing you the example that they did. This is number 2. It's like the first one we did on the board here. Let's erase this. Can you see that they did the first differences? Yes, they did. All right, if we continue, then they divided by the initial output, which in the first one would have been divided by 3.6, the second one divided by 8, the next one divided by 9.6. So we just keep doing that. So let me click continue. All righty, let's see what we got at the bottom of the screen here. Okay, as you can see, they're putting the number down there as they get it. Okay, so there's that number. Continue. Continue. I'm just letting you see that they're dividing. So you can see what they're, once they divide, they get an answer here. Continue. All right, look at all those percent of change that they have here at the bottom. And if I continue, it says, remember that if the percent changes of the outputs are constant for equally spaced inputs, then the function is a perfect fit. Were they the same when it says when they were absolutely equally spaced, meaning that these came out to be the same? Were they equally spaced? No. So it can be seen from the above table that the percent of change is neither constant nor approximate. So you see what it's saying? It wasn't an exact match, nor was it an approximate match. So they're going to say that this one is what? So therefore, the given function is not exponential. That's what they're asking you. Is there a data that'll match this to turn it into an exponential function? Not at all. Not at all. So you got to do the same thing with yours. So we have data here with ours. We'd have to do the exact same thing they just did. What I put over here on the left side of the board, you've got to do the exact same thing for number 2. And let's see what the next one looks like. Make a scatter plot. Does it appear linear or exponential? Okay, you've got to put the data in Zuru. Excuse me, not Zuru, but Desmos. And see if it fits. And it's okay. It still won't matter whether they had negative or positive. It's still, they're not close enough together. Yes.
When I put into 0, it says both x and y volumes be greater than 0.
Which one did you put in Zuru? What number are you?
Number 1. It has a negative. So
How did yours turn out to be a negative for number 1? Let me see. Okay, and you pick power. We're on exponential. Make sure you pick the right one when you're in Zuru, because we're doing exponential now. All right, here, the next one is still wanting you to do the first difference and then do the percent of change.
What's exponential?
EXPR.
Thank you.
Okay, let's see, this one, it says make a scatter plot. Does it appear that there is a linear model or a logarithmic model that's the best fit for the data? Well, let's go back to Desmos again, because now for this one, they want to know if it's going to be a logarithmic or a linear model. So guess what you got to put this data in? It asks a question. You got to put it in Zuru where? For both of them. You got to do both linear and do both logarithmic and see which one of those equations come close to what this data should look like. So, but the first step says to make a scatter plot. Where's the scatter plot gonna go? Desmos. So you gotta go paste the data in Desmos so you can see what your points look like, which are gonna look like one of these 3. Then you gotta go create your equation in Zuru. You're gonna create a what kind of equation? A linear one and a logarithmic one. Well, wait, you like, we ain't did no logarithmic equation in Zuru. Let's try that. Let me copy my data to the clipboard. Right, click in the blue, hit copy. Go to Zuru. We're doing, no, linear. For number 5, it's linear and logarithmic. So they want linear and log. Oops. So here we go. If I go back to, alrighty. So are we, should we be in exponential? Should we? This is number 5. Are we supposed to be in the exponential? No, it wants logarithmic and linear. So your first thing is go create a linear equation. So I'm going to paste my data into the linear one. So you had to go back and click on LR for linear. Paste your data. And you're going to get an equation. Alrighty, so here is my equation that I get. There's my equation, y equals 2.5x. Okay, so here's my equation. I'm just going to write this down so I can keep it for 0.5. Alrighty, what kind of equation do we need next?
The length
the log. All right, which one of these buttons do you think I'm gonna pick? This one. There we are. So the LNR is for logarithmic. Paste my data. All right, there's my data again. I'm gonna delete out the LX, the X and Y. Hit calculate. There's my equation. Now, in here, whenever it writes the equation, it's gonna put natural log as the LN. Doesn't matter, that's fine. So you're gonna type it the same way. So this says, my answer is, and I don't remember if the equation said round to how many places. Does it say on there for number 5 to round to any number of places? Okay, I'm gonna hold on to this information for right now. I'm gonna hold on to 3 places, so that's gonna make that a 7. Log, natural log of X plus 1.124. I'm just gonna hold on to 3 decimal places. It may ask for more. Alrighty, so now what you gotta go do? Put both of these equations in Desmos and see which one comes the closest to all the points. So if I go to Desmos and paste my data, let's close this. Control V to paste my data. There's my data. Can I see all my points? Yep. All right, put your equation in here. What was the first equation we got? Y equals?
0.5x plus 0.5.
Okay, and then put your second equation in. Y equals?
8.667, maximum log 1.124.
Plus, what is it again?
1.124.
Alrighty, so there are both of those equations. Which one is the best fit for this data? The purple or the black? Purple. So the best fit for this data happens to be the linear equation. So if we go back to, so you gotta put the points in so you can see what they look like on the plot. Then go create 2 equations and put both equations in Desmos so you can see which one is the best fit. Bless you. All right, so let me go back to, so again, question here. What's the question? What questions do you have about doing this part?
So, do you kind of determine, which one is a better fit by how many, oh no, never mind.
By how many points it
How many
touches?
points it touches?
Or the
Okay.
or how close, which one of these graphs gets the closest to all the points?
Interesting.
Okay? Questions? Okay, so far so good, right? So this doesn't sound difficult at all, right? I consider this an easy one. All right, let's look at I'm just trying to see if there's anything in the homework that should stand out. All right, this one, look at this one. What does it want you to do for this one? How many equations are you gonna have to create? 3 of them. All right, where do we go for power? Power. Where do we go for quadratic? In Zuru, what do you pick for quadratic? Starts with a P? PR. You're going to pick PR for quadratic, and then, of course, you do LNR for logarithmic. So you're going to need all 3 of the equations for this one. Now, notice in Desmos, they tell you what to make your X and Y axis be. It says create, your X axis is going to be from 0 to 12, and your Y axis is going to be from 0 to 12. So make sure you set your graph like that so yours will look like the pictures that you see on the board. If you don't, it's not going to necessarily look like it, even though it would be the same thing. So make sure you set your scale for your X and Y axis to be just what they set theirs to. Alrighty, so that's.
Do you have to put in the E?
Do you have to?
When you have to put the function to decimal, do you have to?
No, I'm saying, no. It's whatever the equation that Zuru gives you. If Zuru gives you an equation with an E, you can put an equation with an E. But if it doesn't, don't put it. But you can type E in Desmos and it knows exactly what it's supposed to do with it.
That if the E is in zeros, you can send it to decimal.
Yes. Alrighty, let's see. Okay, write the equation. Okay. Oh, here's one of the ones that we were doing with, let me open the screen back up so you can see it better. Remember, we said we're going to use this?
Yes.
Y equals A times parentheses 1 plus R raised to the T power. All right, let's read and see what it says. Suppose the retail price of an automobile is $31,000 in 1992, and it increases by a rate of how much? 3% per year. Write an equation of the exponential function that for the form Y equals A times 1 plus R raised to the T that models the retail price of the automobile T years after 1992. All right, they use the model to predict the retail price in 2005. All right, they just want you to write the equation. What's the equation going to look like? Now, and why are they calling it in the answer choices P of T? Why P? Price. It's for the price. It says suppose the retail price. So we're talking about the price of the automobile. So P of T. Well, we need to follow this format. What's A? The initial. What was the initial?
31,000.
31,000. Suppose the retail price of the automobile is 31,000. So that's the initial price in 1992. And it increases by how much? Okay, so I'm going to buy 1 plus, what should I put in the place of R for 3%? Okay, 0.03 raised to the T power. Am I done? That doesn't look like my answer choices. What should I do now? Add those 1 plus 0.13 together, so I end up with 31,000 times 1.03 raised to the T power. That's what you're expected to do for those. Now, bullet number 2 says use the model to predict the retail price of the automobile in 2005. What now? I have the equation. How do I predict the price of the automobile in 2005?
Put, how many years, 2005 is after 92?
After 1992, so can I subtract those 2 years?
Yes.
Yes, so how many years is 1992 from 2005? That's going to be a 3. What is that? Is that 10 years, 13 years, 15 years? Is that 13 years? Y'all check my math.
Yes.
Okay, so 13 years. So what do I do with that number? Put in for T. So now P of 13 equals 31,000 times 1.03 raised to the 13. All right, question. Is this an increasing function? Yes. How do you know? Okay, A is
31,000.
B, K. You see what happened? It's increasing. This is an increasing function. So we were expecting the price of the vehicle to go up. Weren't you expecting it to go up?
Yes.
I would love it if the value of price of the vehicles would come down. Okay, questions? So this is giving you a good idea of just what you should be doing for the homework. This one is a similar one. Okay, this one is showing a decrease. So instead of 1 plus R, it's going to be 1 minus R. This is number 8. So we're right here, we had the rate was 1 plus R. This one is going to be 1 minus R because it's being decreased by 1%. So again, when you put this one in, it ends up being something like 23,000 times 1 minus 1% raised to the whatever X power. Bless you. And of course, number 9. There's my table. I couldn't see my table at first. All right, so these data can be modeled by an exponential function. Write the exponential equation. Okay, with X number of years after, okay. Okay. All right, questions? That gives you enough information to get a good head start on this 5.4 homework. Yes,
The function in the lessons and it gives you the head that's based off like this.
okay. And then,
Now it's make this that's approximate.
where the dots at? Okay, so you didn't put that in. You didn't put
I
that.
just say this.
Yes, you put it in decimal? Yes, but did you also put it, you put the data in both places? Where's the data? I don't see it. No, in here, where's the data? In here. That's the equation, where's the data? You didn't put the data in, so go back to the homework. Yeah, I know you did, you gotta put it in both places. So now copy your data again. Okay. Copy. Now go to decimal. Okay, come down to this place right here. Right, yeah, there you go. Right click. Okay, yours is much you can paste this, Control V. Close, yeah, click on there. Yeah, now do Control V. Okay, there's your data. Okay, now, does that curve look like it matches those points at all? And so that's the question, that's what you, so you gotta have the points in there with the equation, okay? Did everybody sign the sign-in sheet? No. Okay, here is the sign-in sheet. Just pass it back around. I'm just gonna walk around and see if you're looking at your homework now. That's fine. I'm done, otherwise I'm done.
The last one.
Let's see what you got. Okay, now you wanna know which one is the best fit, because they both look so close.
They look so close.
So you gotta make a judgment. Yeah, that's a close judgment call.
Okay, which one would you choose?
To me, the linear one does look like it's closest to the point. So, like somewhere here, see this curve falls below, but then that black comes closer to those points. This one falls a little above, this falls up. I would say this. I would say that.
That's the only.
That's a good one that, you're like,
Like, that, I don't understand the homework approximately, not exactly.
right.
Cause
It's a judgment, it really is a judgment. It really is a judgment call for those.
Okay.
And you already signed, Robert?
Yes, ma'am.
Okay. Anybody else need to sign? Okay. Hold side.
Calling somebody else. Turn this stuff up. Oh, you want that?
Almost there. I'll make sure you get 10 things, right? You got what, 2 weeks left?
Yeah, one side is a 9 o'clock class, one side is a 10 o'clock class. Because there's a class right before this one that goes with this class. Okay, so what you said, according to the model, what is the price of 2014, so. And you raise it to 16 power. No, that's raised to a power. So, show me how you raise something to a power, on your calculator. So, 1.05. Okay, where do you raise it with power? So Okay, thank you. Yeah, you do that one. Now that one's gonna require that you put, yeah, go ahead, put 1.05. Okay, raise to the power of, is this one? 16 equals. Okay, so that's what you got. Now multiply that times 20, just say times 23,000 equals. And that's what it wants. It says how much, let me see, according to the model, what's the price in 2014?
Okay,
And run to the nearest what?
to the nearest.
Dollar, so it doesn't want any change.
Okay, so just 50.
So 50,000, 2,206. And no, it not be a 12 cents. They don't want the 12 cents. Now, look at your example and make sure your example looks like that too, just to be sure. So for example, you do your question help? So you say, okay, let me just make sure mine looks like there. So you continue and scroll through while I look and see where your button is. See if your answer looks like their answer, final answer.
Yep.
Yeah, that's X to the third power. Oh, it's X to the Y. That's yours. Yeah, it's this button, right, see where it says
Oh,
X
okay.
raised to the Y, that's your raise to any power.
Okay.
So if you put in 1.05 and then hit that button and then put in 16.
Thank you.
Yeah. Lynn, did you sign?
Yeah.
Okay. Alrighty.